So once again, with radical equations, you isolate the radical. So we'll subtract 3 from both sides. And then we undo the radical by squaring both sides. And the main thing to remember, here the square and the radical cancel. When you square a binomial, you need to have 3 terms, right? It's the first term squared, then it's plus twice the product of the terms. So m times a negative 3 is negative 3m, doubled is negative 6m. And then it's the last term squared, negative 3 squared is plus 9. Okay, and so you're just going to solve this resulting equation, which, because it has multiple terms with variables, we move everything to one side. So we have our m squared, we subtract 6m from both sides, giving you negative 12m, and here we add 26 to both sides, giving you 35. And so to solve, the easiest way to solve is by factoring. The two factors of 35, whose sum is negative 12, are negative 5 and negative 7. And so when we solve this, we get m is equal to 5 or 7, and it asks you what's the sum of all the possible solutions, so it's asking you for 5 plus 7, which would be 12 for that one. Again, on this page, the questions I kind of want to go through are even problems, so we're going to jump to the next even question here, because this will allow me to talk through the different types of ways that you can solve quadratic equations. They are, expect to see them. This is, again, something that's going to be pretty commonly tested. Okay, so still on that same page, see if you can answer question 18, please. Here's kind of the 3 forms that you're going to see quadratic equations. Right, if you're given standard form, then the general way that students will tend to solve this is they'll use a quadratic formula. Now, if they can change that standard form into an intercept form, meaning if you can factor it, then you should just use factoring and the zero product rule to solve. Okay, so that means you're going to get rational zeros. Okay? And then the last way is if you can also take that standard form, or if you're given a form, you can convert it into vertex form by completing the square. And then you can solve this by extracting the square root. So these are sort of the 3 different processes that you can go for, or that you can use. Using the quadratic formula and completing the square can happen with every single type of problem. Okay? So when you look at something like this, the first thing, if you scan your answer choices, you see that options C and D are integer values. So I'm going to test those, because if one of those is the answer, I'll get it right away and I'll be able to see. So if I test in a 2, I get 2 plus 3, which is 5, times 2 minus 5. Does that equal 5? No. So C is not correct. I can test for D. If I plug in a negative 3 plus 3 is 0, times negative 3 minus 5. Does that equal 5? No. Okay, now, what this means then is that you have irrational solutions. So you have to use quadratic formula or completing the square. Right? You can't just set the factors equal to 5. That's not how solving by factoring works. Solving by factoring means you have to have the zero product rule. So you could, if you had everything set equal to 0 and factored, you could find it, but not if it's set equal to some other number like the 5 here. So what you're going to have to do in this problem is one of 2 things. Either way, you start out by expanding your binomial product. So if we FOIL this, we get x squared minus 5x plus 3x. I'll vertically stack my like terms. Minus 15, that's all equal to 5. And if I combine down the column here and subtract 5 from both sides, I get my answer. And so this is my standard form now. So if I set this up in standard form, I can solve this now by using quadratic formula. Right? Quadratic formula is negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And you can have that all written as one single fraction if you want to. Okay, where my a value is the coefficient of x squared, my b value, negative 2, is the coefficient of x, and my c value would be my constant. Okay, so one way to solve this would be to plug in b, my a, and here I take a negative 2 squared minus 4a times c all over 2a. And if I simplify this, here I get 2 over 2, which is 1, plus or minus. I get inside here 4 minus a minus is plus. 20 times 4 is 80. And so if I continue to simplify what I'm looking at here, I get 84 over 2, the square root of 84. And right now, I don't even really need to go any further to see. Inside my radical, because I looked at my answers first, are either going to be a 21 or a 5. Well, I can see from this right here that if I take out a 4, I'm left with a 21 here. So I don't need to complete this. Once I see that that's the form I'm going to have, that is my answer. Now, if you are not comfortable working with quadratic formula, and especially for problems that you're going to see on the SAT, which give you somewhat easy numbers to manipulate, like with manual calculations, is you can also, from standard form right here, you can convert this to vertex form. If you want to, you can convert to vertex form and then solve this way, and you do that by completing the square. So if I wanted to, from this step right here, solve this by completing the square, what I would do is I would move my constant back to the other side, and I'll use a different color here to indicate my next step. And then to complete the square, we take half of our first degree term's coefficient. Half of negative 2 is negative 1. We're going to square that and add it to both sides of the equation. So negative 1 squared is a 1. The whole point of doing this is it allows you to write the left side as a binomial square, and it's always in the form x and then whatever this number was, minus 1, equals 21. And now when I extract the root, I can already see what my answer is going to be, right? You have to take into consideration the positive and negative of this root. And now, for adding the 1 to both sides, you get 1 plus or minus root 21. So to me, this process right here is easier than going through what's in green with the quadratic formula. But again, they're both options you can use for every type of problem. The only time I would not complete the square is if the leading coefficient in front of the x squared were some number that's hard to work with, or if it doesn't go into the first degree term's coefficient with the same factor, then I maybe would just go to quadratic formula. But you can use either one of those methods. All right, so I want you to try the next even question. Try number 20 here in a similar fashion. So again, notice you can solve this problem using either of those, the purple or the green method that I showed up above. So you can use quadratic formula, or you can use completing the square. Even though most students will prefer quadratic formula, I definitely encourage you to try completing the square, because if you use it and it makes sense and you understand that process, it's usually a simpler solution. Now, sometimes if it gives you fractions to work with, it can be a little more cumbersome, but for the most part, the types of questions you would see on the SAT would be the easier numbers to manage. Okay, so here we're looking for solutions. There is no answer choices to test. So we need to solve this. Solving a quadratic equation is one of these three methods, right? Standard form, vertex form, intercept form. This is given in standard form. I'm going to complete the square and write it in vertex form, or solve it that way. So if I take this equation, move the 1 over, and then I'm going to complete the square, just like the last one. Half of my first degree term's coefficient is negative 1. Square that, add it to both sides. When I square negative 1, I get 1, so I'll plus 1 to both sides. It allows me to rewrite the left side as a binomial square as x, and then the number that's in my parentheses here, negative 1, and that's equal to 2. Extract my square root. When I do that, I need to take into consideration both the positive and negative root. Add 1 to both sides, just like we did in the previous problem. So here is my solution. And so my n value is 1, and my k value is 2. And so I get my total sum of those to be 3. All right. The next type of problem that was added more recently, but I haven't seen it show up on the version that's coming, the digital version coming out the next iteration of the SAT. I haven't seen equations of a circle, but the equation of a circle has shown up multiple times here in the last couple years. Okay, and so when you're dealing with equation of a circle, again, just a reminder that the equation of a circle is x minus h squared plus y minus k squared equals r squared, where the center of the circle is located at hk and the radius of the circle is equal to r. So that's sort of the breakdown of this. So I want you to try to see if you can remember how to solve this if you've been exposed to it before. And then I'll talk through it, but the process is to complete the square for the x's and for the y. So it's very similar to what we've just done the last couple problems, but you're going to do it for both the x's and the y's in order to rewrite it in that equation form, the equation of a circle form. So when you scan your answer choices here, again, you see you're looking at plus or minus 5, plus or minus 3. But really, the center of a circle isn't going to appear as a solution on the equation. So we can't plug this in and test any of these because the points that work for that equation are points that lie on the circle, not the center of the circle. So if you want to find the center, what you need to do is you need to rewrite that equation in the standard form of a circle. So what we're going to do is we're going to kind of group our x terms and y terms together. I'm going to leave a space here to complete the square for the x's, leave a space to complete the square for the y's, and the constant's going to stay over on the other side. So the process of completing the square here is the same thing that we did in the last few problems. Take half of our first degree term's coefficient, half of negative 10 is negative 5. We're going to square that and add it to both sides. Well, negative 5 squared is 25, so we'll balance the equation here. The whole point of doing that is it allows me to write this as a binomial square, x and then a negative 5. We're going to do the same thing with the y's. We take half of our first degree term's coefficient, half of positive 6 is positive 3. We're going to square that, add it to both sides. 3 squared is 9. And again, the whole point of doing that is it allows us to write a binomial square here as y and then the plus 3, whatever that term is that's in the parentheses. Combine our terms over here on this other side. So 9 and 2 is 11 plus 25 is 36. And so this is now the equation of your circle. You see that the center is located at the value of x and y that give you zeros inside the parentheses. So a 5 for the x and a negative 3 for the y. If we had to find the radius is going to be the square root of whatever's on the outside here, which would be 6. This question is just asking us for the location of the center, and so 5, negative 3 would be your answer. So let's try one more problem dealing with the equation of a circle. Okay, see if you can solve this problem, please. To me, this one's a little bit easier to solve sort of visually, although if you understand the way that the equation's written, you can do it that way as well. But if I sort of sketch what this original circle looks like, it's written in the equation of a circle. So my x and y coordinates of my my center are the values of x and y that give you zeros inside the parentheses, so a 6 and a 3. So that would be the center of my original circle. And then the radius for this is 5, right? It's the square root of 25, so 5. So that means that as I go 1, 2, 3, 4, 5 units down, 1, 2, 3, 4, 5 units up, this is going to give me my circle. All right, so that's sort of where my original circle looks to be located. Okay, so what this is saying is now this is translating this circle down so that the circle is tangent to the x-axis. What that means is, since this is a radius of 5, I need to move this down enough to where this point right here is going to fall here. Okay, and so when you go in to find that, you're simply taking that distance right here. So the top from the top to the center is 5, and then from that center to the x-axis is another, you can see from this y-coordinate 3. And so what that means is the transformation that has to happen is it has to be moved 8 units. Okay, right, so when we look at this, our A value is going to be an 8 for that problem. So you're just looking at how far it is translated to reach that point. So again, now the circle will look like this. All right, the last little bit here of the Algebra 2 material, it has to do with taking graphs of nonlinear functions and interpreting information about them. So most of these are ones that you can solve pretty quickly, so we won't just stick to the odds. We'll probably talk about most of them. Okay, but let's look at this one here. This is one I mentioned before that you would see again. Okay, but see if you can remember how we solved this the first time, and can you find the correct answer for this question? Remember, zeros are the same as solutions are the same as x-intercepts. So we're looking which of these graphs shows 3 x-intercepts. I mean, I already saw it, but I'm doing all of them just to demonstrate. And what we see is the very first one is the graph that shows that it's intersecting that x-axis at 3 different spots. Right. The next question I wanted to go over, it's a simple question, but the type of question is one that you will likely see, so I just wanted to kind of give you exposure to that. So see if you can answer this question, and then I'll talk through what these Roman numeral type of questions tend to be. And so this is the Algebra 2 type of questions that are contained in the calculator portion. So you can use calculators for these, which is why most of them will be graph related. So the calculator is really not going to give you a ton of advantage on it. But when you get these Roman numeral problems, what you're really looking to do is you're just testing the truth or validity of each statement. And so basically you want to find out, is that statement true or false to what the question's asking. So here it says, which of the following are equal to 1? So when we evaluate each of these, f of minus 4, so here if we look, 1, 2, 3, 4, here is the output. This is what f of minus 4 is equal to. We look at its y-coordinate. It is a 1. So that one is true. F of 3 halves, so 3 halves is located right about here. That also has a y of 1, so that's true. And f of 3 is this point right here, also has a value of 1, so that is true. Once you establish the truth of each statement, then you just go in and answer the one that contains all of the statements that are true, or sometimes it's a not true, right? Which of these do not work? And so just know, are you looking for trues or falses? And then identify which list contains all of those based on the condition it's asking for. All right, so again, this is on page 17. Okay, same page. I want you to try the next question here. So what this question is asking, it's very similar to the one of how many zeros are there. So if this had asked for zeros, this is what you would be solving for, right? Well, what this is asking for is not just zeros, but it's asking you to test that 0, at a 2, at the -2, and at -3. Which of these is going to have 3 real solutions? Well, if you just draw a horizontal line at each of those numbers, so if I draw it at -3, notice I have 1, 2, 3. That's actually my answer. I could stop here, but I'm going to go on. -2, if I draw a horizontal line, I have 1 solution. 0, I have a horizontal line there of 1 solution. And at 2, horizontal line, 1 solution. So the only one that has the 3 different solutions that give you an output of -3 is the first option. All right. Next question here goes to, again, thinking about what happens on nonlinear functions, especially quadratics. Okay, when you're looking at maximum or minimum, maximums or minimums, greatest or least, that has to do with the vertex of a quadratic, right? The parabola, the highest point of the parabola is going to be the max. The lowest point is going to be the minimum. So what you're going to do is you're going to look to find the vertex of this equation. Now, again, as a reminder, just like I did with solving for quadratics, you have those three forms: standard form, vertex form, and intercept form. Depending on which form you have, right, so depending on which form you have a different method for finding the vertex. So if you have the standard form, easiest way to find the vertex is to use negative b over 2a to find the x-coordinate of the vertex, and then evaluate that, meaning plug that entire quantity back into the original function and see what the corresponding y would be. If it's in vertex form, then the whole reason this is called vertex form is it just gives you your vertex at the h and k, the horizontal and vertical shifts. And then if you're looking at the intercept form, from x-intercepts, the vertex is located halfway between the x-intercepts. So what you would do is you'd calculate the average of p and q. Those are the two x-intercepts. And then you also evaluate that number, put it back into the original function, and then see what the corresponding y would be. So these are your three sort of options based on what they give you or how you want to manipulate that. Okay, so see if you can find your speed that gives you the greatest mileage. And again, this is in the calculator section, so you can use a calculator to help you with this. All right, so looking at this, the problem is written in standard form. It does have the numbers that are a little more messy to work with, so trying to rewrite this and complete the square, put it in vertex form, probably not the most ideal thing to do. So we'll just use this process right here, and when you're finding what speed, that means you only need to know what the x-coordinate is. So it winds up being a nice, easy calculation. We take negative b, here's our b value, 4, divided by 2 times, here's our a value, negative 1 over 24. And so when I simplify this, my negative signs cancel, 2 goes into 4 twice, and dividing by 1 over 24 is equivalent to taking the numerator 2 and multiplying by the reciprocal. And so that gives me my answer, 48, a nice, easy, manageable calculation. Okay, now, if I wanted to find what the corresponding y-coordinate would be, I would take that 48, plug it into each of these s's and evaluate. But it doesn't ask us for this. We can just stop right here. It only wants to know the speed. Now, the other thing with the SAT is that when they use models for things, the models are realistic. Okay? And so if you knew sort of history about like speed limits, have you guys ever been exposed to why the speed limits were set to 55? So in the 70s, there was a gas crisis, and so they were limiting the amount of gas, and so they changed the speed limit to be closer to what the maximum efficiency was, so that people wouldn't be wasting gas. So around 45. I mean, and this is pretty close. Around 45 to 48, 50 miles per hour is like the most optimal driving for the cars back then. There's a little more efficiency now, but so 48 does seem realistic. Now 75 though, completely unrealistic, right? Because if that were the case, I mean, the speed limits would be higher. It's not as much as safety as it is, although now it's a little bit more toward safety. But if you just recognize that all your model answers are realistic, if you get an answer that doesn't seem realistic, double check it, or if you're in the stage where you're just guessing from the remaining answer choices, you can cancel out and guess from the remaining ones. All right. This question is the very last question on a section. Okay, and that is important. There are arguments about whether the SAT is or is not arranged from easier to harder, but it is. Every single one has been when you look at it. The last couple questions are always the hardest ones. Okay? So when you look at this question, one of the things to be very wary of is if you're doing one of the last questions in a section and it seems too easy, there might be something tricky about it. Okay? And so part of the reason I run through this problem is that there is a really easy graphical way to solve this problem. Okay? But if you do that, you might fall victim to a common mistake. So the idea is be aware of where the questions are located, and if you get a hard or an easy question at the end of a section, it might not be as easy as what you maybe originally think. Okay? But see if you can answer this question here, and then I'll talk through it. If you solve this equation algebraically, you probably won't fall victim to the mistake. It's only if you solve it visually and graphically that you would likely make the mistake. When I show it to you, I'm going to do the mistake first, and then I'll come back in and show you why it's a mistake, and again, why you might want to be cautious. So in this problem, they give you the first equation, the parabola, and it tells you that it intersects with this linear form, which is a really easy graph to sketch, right? Because this one has a y-intercept of 10, and it has a slope of -1. So if I go down 1 over 1, and I keep going down 1 over 1 using my slope, what I can see is this would give me an answer of 3/2. Okay. Seems really easy, didn't take long at all, but there's a reason why it's at the end of a section. Okay. It's more students miss it than get it right. Okay. So it's not that the questions are harder necessarily, it's just that fewer students get them right. Okay. So if you're trying to solve this visually, did anybody see the mistake I made? Great. Yeah, so notice the scaling of the x's, right? The x's don't scale at one block. Each of the blocks on the x's are 1/2, each of the blocks on the y are 1. So I did the right thing, but I did it the wrong way because when you look at this and you go down 1 over 1, actually has to go over 2 units to get 1. So I go down 1 over 1, so here's one solution, down 1 over. And if you keep this up, now you'll get your 2 possible solutions. So your answers could have been either 2 or 8. But if you made that common mistake of not seeing the scaling, you might answer it incorrectly. Even though you know how to do it, just be careful. So any questions that come at the end of a section, be cautious.